Good morning dear students. I am going to continue the next session regarding the concept using the lens. Okay. In the previous class I have obtained the equation of lens maker's formula. I also distinguished the difference between the convex lens and the concave lens. Okay. Next, depending upon the position of the object in front of the convex lens, we have obtained the real image as well as virtual image. Okay. Whereas in case of concave lens, the image will be always virtual. Next, one more term, that is linear magnification. We can define the term linear magnification. It's the ratio of the size of the image to that of the size of the object. Okay. We will also get in terms of image distance to that of the object distance. Image distance to that of the object distance. So magnification can be positive or negative. If we get the magnification value as negative, then the image is said to be real. Okay. If magnification value is negative, image is said to be real. If magnification value is positive, image is said to be virtual. Okay. Next, in case real, in order to obtain the real image, three possibilities are there. When object is beyond 2f. Okay. One more thing, when object is exactly at 2f. Next, one more thing, when object is between optics and between f and 2f of the given convex lens. Okay. In case of when object is placed in the exact on the 2f, magnification value will be equal to 1. Okay. When object is exactly kept on the 2f of the principal axis, then the magnification value will be equal to 1. That is how in case of convex lens, if the position of the object is on 2f, then we will get the image on the another side of the 2f. That nature is real, invert and of same size. Real, invert and of same size. The formula size height of the image to that of the height of the object. If I take h as the height of the object, as I already said, size of the image when the object is kept on 2f, the size will be same. Here h will be equal to hi, which is also equal to h naught. Next, what about the magnification value? Magnification of the convex lens will be 1 when object is kept on 2f. Okay. So it may ask for the CET exam or 1 marks in your annual paper. Next concept, power of lens. How we can define the term power of lens? So it measures the amount of convergence or the divergence. Whatever the rays of light get incident on the convex lens or the concave lens, it measures the at what extent rays has been converged. That is in case of convex lens, and rays has been diverged. That in case of concave lens. Okay. I will consider the convex lens. Principal axis, exact center, optic center. Okay. I will consider one ray which is incident parallel to the principal axis. Okay. The ray is incident parallel to the principal axis, undergoes diffraction twice at the first surface and the second surface. Whenever the ray of light is incident parallel to the principal axis, it passes through the principal focus of the another part of the lens. Okay. So let this angle be If it is theta, this value will be equal to theta. Power of lens, it is a tangent drawn. Okay, tangent drawn at a particular distance of the optic center of the lens, where this ray start to converge or start to diverge from a particular point. Okay, at particular distance from the optic center, one tangent has been drawn, and after that the ray of light falling on it, either it converges or diverges. Let this distance be h. You know that distance from optic center to the principal focus is what? Focal length. Amount of convergence, that the angle tangent of the angle, that is tan theta, will be equal to h by f. This value by this value. Okay. Here tan theta itself is the power of lens. Here the distance should be a unit distance, that h value should be equal to 1. So power of lens will be the reciprocal of the focal length of the given lens. Power of lens can be also defined as the reciprocal of the focal length of the lens. Okay. You may ask to find out the power of lens. If the focal length of the lens has been given, automatically or directly you can find out the value of power of lens. So we can also classify the convex lens depending upon the focal length value. For convex lens, focal length is positive, whereas in case of concave lens, focal length is negative. Similarly, for convex lens, power is positive, and for concave lens, power is negative. Okay, you can add this one more difference. So this concept is regarding the power of lens. Here, especially the focal length in terms of meter or centimeter, the SI unit of the power of lens will be diopter. Okay, it's the SI unit of the focal length of the, SI unit of the power of lens. That is, you can write simply D or in totally diopter. Okay. Next, what happens if two lenses are kept in contact? What happens if two lenses are kept in contact? Next, that is, you have to find out the expression of equivalent focal length when two lenses are kept in contact. That is nothing but combination of lens. Here I am going to consider the two convex lens of different focal length which kept coaxially. So here the lens should be thin lens, not the thick lens. Let L1 and L2 be the lens kept on the principal axis of the lenses. Next, and it passes through the optic center of the both the lens. Here, let F1 be the focal length of the lens L1 and F2 be the focal length of the lens L2. So, focal length of the lens L1 and F2 is the focal length of the lens L2. Here, I am going to use the thin lens formula. What's the principal axis. One ray passes through the optic center of the both the lenses without any deviation. Okay. Next, one more ray get incident on the first lens, undergoes refraction. After refraction, the ray of light passes through the lens L2 once again. It undergoes refraction. Finally, it converges at a point set as I. So, O is the point object and I is the real image obtained on the principal axis of the another side of the lens. Okay. So here let's consider the first portion, that is only one lens. If I consider only one lens, if it is lens L1, what happens? The ray O which passes through the principal axis, it will be undeviated, and one more ray, this ray get incident on the first lens. Finally, after refraction, it converges at a point. Instead of I, it meets somewhere at the point I dash. Okay. Directly I am going to use the thin lens formula. If I use this equation, what I will get? So here, from here to here, it's the object distance u, and from here to here, image distance v dash. That's the first image of the first lens. Okay. And f1 is the focal length. I can write the equation 1 by f1 equal to 1 by b dash minus 1 by u. Okay. So equation what I will get? 1 by f1 will be equal to 1 by b dash minus 1 by u. So f dash means focal length of the lens L1, b dash means the image distance of the first lens, and u is the object distance. It's the first equation. Okay. Next, if I consider one more lens nearer to this, already the rays has been converged. In the direction of converging ray, what has been kept? One more lens has been kept. In the direction of the converging ray, one more lens has been kept. In this case, I dash will be acted as a virtual object. So, for the second lens L2, I dash act as a virtual object. Okay. So, when this converging ray get incident on the second lens L2, undergoes refraction, finally meet somewhere at the place I. So, I is the real image, nothing but final image of the when two lenses are kept in contact. So, what happened here? When I kept the second lens in the direction of the converging ray, what happens? It undergoes refraction and it converges early at the point I. Here, I dash act as the virtual object. What do you mean by virtual object? When the converging rays are made to incident on the optical medium, and after refraction phenomenon, it finally meet at a point. What you should remember, in the first case, that image was real, and for the second case, that real image acted as a virtual object. Okay. So for the second lens, what's the focal length? Focal length is f2. Focal length is f2. I can write the equation 1 by 1 by v minus 1 by u. If I compare the right hand side and the right hand side of this equation, I can replace the equation, this part 1 by f1 plus 1 by f2 will be equal to what? 1 by f. It is the equivalent focal length when two lenses are kept in contact. In the earlier definition, what's the relation between power of lens and the focal length? That's the reciprocal. I can replace this equation simply P1 plus P2 equal to P. Okay, that's the power of lens when two lenses are kept in combination. If there are n number of lenses, I will get the final expression or the equivalent value, that is 1 by f equal to 1 by f1 plus